Hey there, CP remote learners. Happy Friday. So I've had tech issues all day. This is the first time that I've even been able to get both audio and video working at the same time. So you don't get an actual teaching period in person, but this is fine. So let's get started. First of all, actually, don't forget your only real homework besides the Chapter 4 guided reading is to complete that survey I posted earlier today. Super important because it'll help me kind of guide what I do going forward, and I'll do one of those every once in a while just to kind of take your temperature.
Pardon the interruption, Nicholas Middleton. Please come to the front.
And to kind of help me figure out what's working and what's not. So please take the time and do that. It's worth 5 points, and it's just honestly a thing that you should do to help yourself. All right, let's get started. We are looking at this is day 3 of ecology. There's something that they tell me I don't need to teach you, but I'm going to go ahead and mention it. Food webs, which I'm going to assume you know that when there's a relationship between two organisms in a food web, it's because one eats the other, right? What some of you might not remember is what you draw between those organisms. You might remember it's an arrow. I hope what you remember is that the arrow always goes a particular direction. If you remember, since the arrow represents energy, that arrow should be going from, who's doing the eating, from who's getting eaten, right? The prey to the predator, right? So the arrow represents energy, which means that you're always going to see it going from, say, what is it, a prairie dog? I don't even know. Prairie dog to the vulture that eats dead ones, the prairie dog to the mountain lion or whatever that is that eats the prairie dog, not the other way around. Some people sort of think, well, the arrow is like the predation, and so it goes towards the prey. It doesn't. It always goes to the critter doing the eating. So we're going to move a little beyond that, beyond food webs, and start to talk about ecological pyramids. Ecological pyramids are a way that we describe and show how energy and biomass and numbers of organisms fall into different trophic levels. Remember, trophic levels are simpler than they seem. It's just how many steps you are away from the sun. So energy pyramids will show how much energy is at the producer level and the primary consumer level and the secondary consumer level and the tertiary consumer level. And the question you're going to get on a test, I promise, it's a question I always use on this test, and I'll just be upfront with you and say you're going to get a test that says, why do we use pyramids to describe the energy distribution in trophic levels? And what you don't want to say, write this down. Don't say, we use pyramids because there's more producers than there are primary consumers, and there's more primary consumers than there are secondary consumers, and that's why it's pyramid shaped, because there's more at the bottom than there's at the top. I know what a pyramid looks like. You don't have to tell me that. This is a question where I want to see if you understand why. Why is it a pyramid? And so the example I use, like the example I used yesterday, where I talked about the hippo and how one of our students gets eaten by a hippo, then what I asked that student today in class was, okay, well, walk us through your morning. What did you do this morning? And I got out of bed, I brushed my teeth, I ate breakfast, took the bus to school. Why didn't I even tell you this? I don't know. I guess I went to Commons and then I went to class. Why? Well, the question is, of all those things, which ones cost energy? Well, all of them, right? Now, when the hippo eats you, does the hippo get any of the energy that you used to brush your teeth? No. To get out of bed? No. To walk to class? No. Doesn't get any of that energy. I used it. That's it. That energy actually gets lost. And so the reason that there is a pyramid shape here is that there is a bunch of energy lost from one trophic level to the level above it that eats it. All the stuff this trophic level did during its daily life, all the energy it spent, predator doesn't get any of that. Okay? So that energy gets used, and what a lot of people don't know is, that law of conservation of energy where it can't get created or destroyed. What happens to it when you use it is it turns into heat. It is lost to your environment, the atmosphere, basically, as heat. which is kind of cool. The other thing is sort of a loss, not completely. Decomposers get it, but the predator doesn't also get the calories that you didn't get from your food. So incomplete digestion, to put it nicely. Okay, so what is the thing that this student I'm talking to who got eaten by a hippo, what can they do with that energy that the hippo would get? Well, the thing they could do that they're still doing, that I'm done doing, is growing. So growth, anything you use, any energy you use to build more of you, that is gonna be transmitted to whatever's eating you. It's really the only thing you can do with energy. I guess maybe if I'm growing like this way, fat is worth a lot of calories. But yeah, so the only energy you pass on to what eats you is the energy you use to build more of yourself. So let's look at a sample energy pyramid. You will notice that it's exactly 10% that's making it from one level to the next. That's called the rule of 10%. And so that means 90% of the energy is being lost from one trophic level to the next. 90% of the energy was used for life processes and is not available to whoever's eating the level below it. And so I used both percentage here and a unit of energy called kilojoules, just to show you that if it was 5,000 kilojoules that all these critters in this producer level add up to, then the primary consumers would only be getting 500 kilojoules of that energy, if that makes sense. Okay, so that's an energy pyramid. It's always exactly 10%. A biomass pyramid, by comparison, is still very much a pyramid, and it might be close to 10% that's going up, but it's not going to be exact because different kinds of biomass, and biomass is the amount of living tissue, right? The mass of living tissue minus water usually, that is in each of those levels. It's not exactly 10% because different tissues are worth different amount of energy, right? Fat is super energy rich. Carbs, pretty rich, right? Proteins, maybe not as much. So it's a little off just because different tissues are worth different stuff. But it's mostly like the energy pyramid. The weird one is our final one, the pyramid of numbers, which instead of biomass or energy just counts how many organisms are there at each level. Now, some of them can look pretty normal, like a meadow ecosystem, a grassland where all the producers are real small, might work. We got 2,500 grass plants maybe supporting 1,000 primary consumers, supporting 300 secondary, and so on. Still a pyramid. Where the pyramid of numbers starts to look funky is when there's anything that's especially large, that has tons of mass, which means tons of energy, but it's still only one organism since we're only counting organisms. And the one that looks the weirdest, but makes the most sense, is the one that has our largest producers, which of course are trees, right? So forest ecosystems are going to look weird, and they're going to look weird because, one tree supports, in some cases, thousands of primary consumers. So they look like this, right? They got this bottom that's skinny because 75 trees that's a decent sized forest, and we're supporting 2,000 primary consumers on those trees, right? It gets smaller as you go to the top. That's pretty much universal, but that little base makes it a weird shape because of the trees. So 2 questions you can expect to see on the ecology test are, number 1, why do we use pyramids? And the answer has to do with the energy loss. You have to be talking about how energy is lost, how it's lost, in between those levels. And then the second question is, how come pyramids and numbers can look weird, right? And the answer is, well, when there's large, oversized organisms like trees, they're worth so much biomass, this pyramid doesn't take size into account. And so it's going to look funky because of that. Final thing here is we can use this concept to really understand this question that you started with in your intro activity, that humans like to kill predators. It's just kind of part of our nature. We see a predator, we worry about our children and our pets, and we try to kill it. And the question is, why was that so easy? It didn't take us, but, European settlers, but like maybe 50 years, 100 years to get rid of most of the top predators. This area is no exception, right? There's no bears or wolves or mountain lions here, or if there are very few of them. We did that fast. And so the question is, why was that such an easy thing to do? Why did it take so little time to clear all the predators out of here? And of course, the answer is right in that pyramid of numbers, isn't it? Because look, there's just not many of them. If there's 50 wolves in Ohio, right? I mean, they say it takes like 100 square miles, or I can't remember the number, but it takes a lot of square miles of like African savanna to support a small group of lions. And so it takes a lot of Ohio to support, limited numbers of bears and wolves and whatever there was. So killing one of them is actually a much larger percentage of the population than killing, say, a deer, which of course there's tons of. Hope that makes sense. Please continue asking good questions like you've been doing. And your only homework besides the chapter 4 guided reading, which I think I have as due Tuesday, is that survey. And I can't stress enough that is something you really need to fill out. Other than the 5 points, it really helps me steer what I'm doing. Okay. Hope you have a great weekend. See you on Monday.